inertial guidance system. It was made up of gyros and accelerometers. It sets the vehicle in space and lines it with the stars. It also contains the rendezvous and landing radar. The rendezvous radar I mentioned before was used for rendezvousing with the command module at the completion of the lunar mission. The landing radar was a Doppler radar, and it actually laid out, I guess, like kind of a square of where the lunar vehicle would be landing. The navigation and guidance and radar subsystem was also had automatic and manual control for descent and ascent of the lunar module, and also control the reaction control system, which stabilized the vehicle while in space away from the command module. The structural subsystem was responsible for the exterior structure of the vehicle, was also required to provide micrometeoroid shielding for the ascent engine and thermal shielding for the ascent stage, and thermal shielding for the descent stage of the lunar vehicle. What else can I tell you about it? It was also responsible for the support of the engines and for the antenna structures. So they were responsible for that part of it. The communication subsystem was a very, very important subsystem. It was developed by RCA, working with the subsystem engineers. RCA was, I think, housed in Boston, and it was a very important part of the vehicle. It provided communications between the lunar module and the astronauts when they were away from the lunar module, between the LEM and the command center in Houston. By the way, I mentioned at first that the responsibility for launch was that of the Cape with Wernher von Braun. The responsibility, once the vehicle was on its way to the moon, responsibility for control of the mission went to NASA in Houston. Communications between the LEM and, as I mentioned, Houston, communications between the LEM and the command module, and communications between the LEM and the lunar rover, which I'll talk about in a little while. Communications. Propulsion consisted of the descent engine and the ascent engine, both liquid propellant engines, as well as the reaction control rockets, all liquid propellant engines, kerosene, fuel, and oxidizer. The reaction control system we talked about, the 16 little rocket engines providing the control of the vehicle when away from the command module. The instrumentation subsystem processed 250 measurements during the mission for display and caution and warning and telemetry. And I'll talk about caution and warning in a little bit, reliabilities, engineering's contribution, working with the subsystem engineers in developing the caution and warning system. The displays and controls were for the overhead and forward displays of the vehicle. Next chart is a repeat of the lunar module. I guess you don't want to show me that one, but that's all right. Let's go to this one. Okay, so now, if you recall earlier in the presentation, we talked about the launch towards the moon. So now we're on towards the payload. The payload consists of the lunar module, the command, and the service module. The shroud gets jettisoned so that the lunar module gets exposed. The command and service module, I might as well point to it. The command and service module separates itself from the lunar module, positions itself so that it can dock with the lunar module. The combined command module, lunar module, command module, and service module, they are now set in a position where they're on their way to the moon and lunar orbit. Okay, so an additional thrust by the service module starts the process of orbiting around the moon, and then the next chart shows, okay, the next chart shows the two astronauts have now entered the lunar module. The command and service modules separate by about 1.25 miles away from the lunar module to allow the lunar module to now slowly make its way down to the moon. And the next chart shows, that the descent engine is now starting to burn, and it now positions itself so that it's slowing the vehicle. The descent engine acts as a retro rocket, slowing the vehicle out of orbit towards the lunar surface. And the next chart one before that. The one before that. Okay. I lose my place. Okay, I think I wanted to show that anyway. Yeah, that's a good chart. Okay, this is just to remind me that this reminds me that at the end of the mission, now we've already, the astronauts have now descended out of this hatch. They descended down, and they are now doing lunar exploration. They're doing sample collection and things of that nature. Then at the end of the mission, they'll ascend through the hatch and into the ascent stage of the lunar module. The descent stage acts as a platform for the ascent engine to blast off, to rendezvous with the orbiting command module. And again, the command module pilot remains with the command module in orbit so that they will rendezvous and through this hatch re-enter the command module. The lunar module mission is now complete. Okay, the next chart. It eventually gets jettisoned. Okay. Okay, this is my group. Clem reliability. Excuse me. All right. Unreliability as my group. At one point, at its peak, we had about 120 engineers. These guys were engineers, scientists, PhDs, and people from all over the country and different kinds of expertise. But they were based in reliability engineering. We had oversight over every phase of the mission. We had a specification to achieve a mission success probability of 98.4% and a crew safety probability of 99.7%. As I said, we had oversight in every phase of the mission. In order to achieve that mission success probability, we had to do many different things. During the preliminary design of the vehicle, we had to select the highest reliability, lowest failure rate components. We accumulated massive test hours to gain confidence in those components' ability to withstand the entire mission of the lunar mission. During preliminary design, we developed schematic models of each subsystem and postulated every conceivable type of failure that would occur. And in a very formal way, documented, we asked the following questions, this and many other questions. Could we detect the failure if it happened while we were on the mission? What was the probability of occurrence of that failure? What was the effect of that failure on that subsystem or on the adjoining subsystems or on the vehicle itself? What was the corrective action, and would it be available in time in order to continue the mission, or was there corrective action in the event of a crew safety issue to be able to save the crew? During the building and test phase of the program, we were responsible for what was called failure analysis and corrective action. We were responsible for reporting every failure to NASA. NASA had General Electric engineers that were assigned to be one-on-one with my engineers to report back to NASA on the cause and corrective action of each of those failures. Obviously, it caused a contentious situation between my group and the GE people, because their job was to report back to NASA. Our job was to find the cause of failure and get corrective action. And there was a constant calling back and forth. It became such an issue, such that I had to call my counterparts in NASA, and I told them, I'm declaring a moratorium on all calls from GE for at least a week so that my people can catch up and do their job. I was responsible for the failure analysis and corrective action lab. That lab was tasked with finding the cause of every single failure. It was kind of a forerunner of the CSI labs that you see on television. We could slice and dice the smallest possible components and find the cause of failure. We had an electron microscope that was capable of magnifying 300 and 400 times. We were also, I guess I mentioned or should have, that we were responsible for reporting every failure to NASA. So my group was working with the subsystem engineers, finding cause and corrective action. And it was a very serious situation, because if we found a failure that was common to other parts of the vehicle, or common to perhaps the command and service module, we had to report via a NASA alert to the people in Downey to tell them about a problem that could possibly affect the command and service module. And we also supported